Hello everyone, good morning. This is Mr. Dhakshunhaamoorthiy. Today's topic is Monte Carlo algorithm in Unit 2, Monte decision process and dynamic programming. Monte Carlo algorithm, that is model free reinforcement learning algorithm. Model free, that means in policy and value iteration algorithms, assumptions includes the agent that has access to complete model of the environment. Transition dynamics, possible states after each action. No need to interact and the calculations were predictable, including rewards. This is impractical in many scenarios and environments. So we need agents that interacts in environment to learn policy. MC definition, that means Monte Carlo definition. Monte Carlo methods works based on experience sampling. Experience sampling is sequences of states, actions and rewards from actual or stimulated interaction with an environment. Not predictable before a real try in many cases. Monte Carlo methods are the ways of solving the reinforcement learning problem based on averaging sample returns. Monte Carlo methods can thus be incremental in an episode by episode sense, but not in step by step online sense. Monte Carlo methods aim for learning the state value or action values functions based on which approach we are using, either state value method or the action value function method. Simple average the returns observed after visits to that state. More returns are observed, the average should converge to the expected value. What was the state value function? The value of the state is the expected return. What was the action value function? The value of the each action is state is expected return. Known as Q value. What is expected return? Expected cumulative future discounted reward starting from that state. Different versions of Monte Carlo algorithm. First visited method, MC prediction. The first visit MC method estimates V pi of S as the average of returns following the first visit to the state S based on the state value estimation of value function. Every visit method, second method is every visit method MC prediction. The every visit MC method estimates V pi of S as the average of all visits to the state S based on the state value estimation of value function. Exploring starts method MC control, that is based on the state action pair. MC epsilon greedy MC control without exploring starts. These are all the four different versions of Monte Carlo algorithm. First visit method MC prediction. Here policy pi, number of episodes n underscore ep, output value function v, initialize returns equal to 0 for all s, it's a subset of capital S. Initialize n of s is equal to 0 for all s, it's subset of s. For episode E is equal to 1 to n underscore ep, we will start the loop, generate an episode s naught a naught r naught s1 a1 r1 dash 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 sr minus 1 ar minus 1 and rr using policy pi. T is the number of steps. G is equal to 0 for step t is equal to t minus 1 to 0. We have to continue this loop. G is equal to gamma g plus rt plus 1. If such of st equal to false, then return st equal to returns st plus g. And then n of st equal to n of st plus 1. This loop is getting ended. Then the final return v of s is equal to returns of s divided by n of s for all s belongs to capital S. The function Boolean search state parameter state st, the loop starts from 0 to t minus 1 in episodes, then return true, else false. In the Monte Carlo first visit Monte Carlo method, here in the tabulation they given the reward table and the value function table. Value function value is updated by using the reward table. They given episode 1, episode 2, episode 3 paths. Based on that, we are calculating here first visit Monte Carlo calculations for state S4. S4 v of S4 equal to minus 4 minus 5 divided by 2, that is minus 4.5. So the based on the above formula they given S4 up direction reward 4 is calculated by using S1 right direction R1, S2 left direction reward R2 and S1 stop R1 reward. So by using this E1 episode E1 we can calculate, and episode E2 is null. Episode E3 is calculated S5 left and reward R5. For that we are calculating S4 up direction reward R4, S1 reward R1 and S2 stop reward R2. So with this formula we can able to calculate episode E3, and then we are getting minus 4 and we are taking the minus 4 minus 5 divided by 2, then we are getting minus 4.5, that is updated in the S4 cell. So every visit method MC prediction, here the policy pi number of episodes n underscore ep output value function v and initialize returns of s equal to 0 and initialize n of s is equal to 0. The episode E starts from 1 to n underscore ep and generate an episode using policy pi, where t is number of steps, g is initialized to 0. Now we are starting time step t is equal to t minus 1 to 0. Then g is equal to gamma g plus rt plus 1, return of st equal to return of st plus g, n of st equal to n of st plus 1. So this iteration will continue till the time step is completed, and v of st s is equal to return of s by n of s for all s belongs to capital S, return the v. This is the every visit method. Example, environment path planning. Here the problem, a robot needs to go from start to target position. Reward plus 100 for target and minus 1 for each step. Q value for simplicity all zeros. So first step we can see here, we assign arbitrary policy up, down, left, right values first. So arbitrarily it is placed in the arrow marks are left, right, and up and down arrow marks are placed initial state. Now in the B, select a random state S and a random action environment. Then we are selecting state S7 left, then S7 left. That means we are shown here in the blue color arrow mark towards the left direction it is going. S7 to S6 it is moving left direction. And we are having possibility to move right and up also, but we are taking random state is S7 and the random action is left direction movement we are choosing. And next step what we are doing is generate an episode by policy pi t steps comma 6. Start from the selected random state S and run selected first. So S7 comma L, generate episode 1, then S7 comma L is equal to where it goes S6 comma right direction, and then S7 comma right direction, S8 comma down, and S12 comma down, and S17 comma left, and S16 comma left. So this is the pathway they given. So based on that, here discount factor gamma is equal to 0.9. We are substituting here gamma g plus RT plus 1. So in the first S17 comma left we are taking. S17 comma left is gamma g. That means gamma is 0.9, g is 0. Initially g is 0. Then we are getting r of t plus 1 is minus 1, because every step we can apply minus 1. Then we are getting the value minus 1 at this place. Now new g value is minus 1. In the next step S12 comma d, here 0.9 into the previous g value is minus 1 and minus 1 as per the formula. The reward value is minus 1. So in the previous values whatever we found, we are applying in the next steps S8 and S7, S6 and S7 steps, so that we can able to find the finally S7 comma L is the minus 4.685. Then S7 comma L value is updated in the particular place. Update the policy is the sixth step, that means fifth step, sorry. Here arrange the list. Here the list is in the random manner they given. Here S7 S17 left is equal to minus 1, then S17 left is equal to minus 1. Whatever the values we calculated in the above written list, that we are just mapping here. Now generate episode 3 S12 up. A random state is S12 and direction of movement is up direction. So S12 up is equal to, see the diagram, S8 right direction, S9 up direction, and S3 left direction, S2 is also left, S1 is also left. So S0 is stop there. No, this is the state we want to reach out. So s naught comma stop. Update pi of s. Now we are calculating same like that, s17 comma l using gamma g plus rt plus 1 formula, from which once we reach the final state, the reward value is 100, whereas in the normal steps we are applying -1 reward value. From that we are calculating the s q of s12 comma u is equal to 54.953. The arbitrary policy and updated policy after 4 episodes. After reaching the target position, we are comparing these two. And idea in some problems we cannot calculate all the edge cases. For example, in an application that resetting the environment always goes back one state, not random one. In such cases, MC exploring start becomes infeasible. Solution for that problem, we are having solution. We eliminate the random selection for all starting points from MC exploring starts, and apply a random policy sometimes by epsilon greedy techniques. On policy Monte Carlo control. Here on policy first visit MC control for epsilon soft policies and estimates pi equal to pi star. Here algorithm parameter small epsilon greater than 0 initialize the policy pi an arbitrary epsilon soft policy. Pi of s comma a belongs to R arbitrary for all s, and a is also belongs to capital A of s. Returns s comma a empty list for all s, it belongs to s, and a belongs to a of s. Repeat these episodes and generate initially generate g is equal to 0, and then we are trying to do all the time steps. T is equal to t minus 1, t minus 2 till 0, then g is equal to gamma g plus rt plus 1. So we will get the returns. Append g to returns st comma at, then q of st at average returns st at, and then a star argmax of q of st comma a. So finally the pi of a, given that st is equal to 1 minus epsilon plus epsilon by modulus of a of st, if a is equal to a star. If a is not equal to a star, epsilon by a modulus of a of st. Thank you.